Section 1 is all about solids, liquids, and gases, the states of matter. Now remember that Chapter 2 is about how matter can change. One of the most common ways that we see matter changing is in its state, from solid to liquid to gas, and then back and forth between those three. There are two objectives that go along with this section. The first is to be able to define and differentiate, that means tell apart, solids, liquids, and gases in terms of whether or not their shape can change and whether or not their volume can change. The second objective asks you to compare the particle motion in solids, liquids, and gases. In other words, how do all of those little particles that make up a substance move? When we're talking about particles of matter, we're talking about atoms and molecules. We talked just a little bit about atoms and molecules, we called them compounds, in Chapter 1, Section 3, when we were talking about the history of atomic theory. I like to remember that matter is made up of atoms and molecules using the mnemonic, my friends, atom and molly matter a lot. I figured I made you guys come up with a mnemonic for Chapter 1. I throw one out there for even Chapter 2. So all matter is made up of these tiny particles called atoms and molecules. And these atoms and molecules, these tiny pieces of matter, can change in their state pretty frequently, pretty easily. The states of matter are the physical forms in which these atoms and molecules are going to exist. Solids, liquids, and gases are the most common of those types of state, but they're not the only ones. Think, for instance, about water. What are the common states of matter for water? Well, when water is a solid, we call it ice. When water is a liquid, we tend to just call it water, right? The stuff that comes out of our sinks, the stuff that we drink. And when water is a gas, we call it water vapor. So all H2O, all the same molecules, but different in the way that they present themselves physically. In terms of the way that particles move, there is a pretty dramatic difference between the solids, the liquids, and the gases on a molecular level. That means looking at those individual molecules. The particles of a solid move, but they don't often move fast enough in order to overcome all of the attractions that hold them together. And so we notice that they keep their shape, but if we were to look at them under intensely high magnification, we would see that they're actually vibrating back and forth. They're trying to pull apart, they just don't have the energy to do it. The particles of a liquid are able to move fast enough to overcome some of those attractions. They don't have to sit in the same place anymore. These guys are fluid. That means that they can move around. They can slide past each other, but they don't have enough energy to go just anywhere they might want to be. Particles of a gas have the most energy of all. They have so much energy, in fact, that they're able to not just move around one another and change shape, but they're able to counteract gravity, and they're able to fill up an indefinite volume. They can take up as much space, they can fly as far away from all those other particles as they want to. Taking a step back now, let's look at each of these in a little bit more depth. So a solid is a state of matter where the volume and the shape of a substance are fixed. That's just a fancy way to say that the volume is never going to change in a solid and the shape is never going to change in a solid. It's because these particles are stuck so closely together. There's a strong attraction between them and they don't have enough energy. They're not able to move fast enough to overcome these bonds. They're vibrating in place, but they can't break apart. There's only one time when those particles stop moving completely. I don't know, maybe you know what that's called? Absolute zero. I'm not going to play this video now, but I'm going to post it on my website so that you can learn a little bit more about absolute zero after you're finished with this lesson. There are two distinct types of solids. Remember that the particles in a solid are stuck together, but they can be stuck together in a regular pattern or in an irregular pattern. If those particles are stuck together in a regular, a regimented, a consistent crystal pattern, then we call that solid a crystalline solid. You hear the word crystal in the term, right? Crystalline solid. Crystalline solids include ice, snow, sugar, salts. There are lots and lots of them. One thing that makes a crystalline solid unique is that it has a distinct melting point. That means that it's going to melt at the same temperature no matter what. Think about ice, right, as being a crystalline solid. Ice, or water, has a distinct melting point. An amorphous solid is a solid where the particles are not arranged in a regular pattern. I think of them sort of like the cotton candy that you see here on the screen. So instead of having distinct melting points, amorphous solids like plastic or rubber are going to just slowly get softer as they warm up. The word plastic actually means able to be molded into many shapes, and that's exactly what an amorphous solid is going to be able to do or have done to it as it starts to soften, as its temperature starts to increase. As temperature is increasing, what's actually happening, and the reason we can suddenly start to change the shape a little bit, is that the particles are gaining energy. They're gaining the ability to move ever so slightly away from one another. Just want to make sure we're all on the same page with a root word in. It's a prefix, so it's always going to come at the beginning of the word, and when you see it, it's telling you that something in this word has to do with not or without. So if we look at the examples down at the bottom of the screen, if something is inefficient, it's not efficient. It's not probably the best or fastest way to do it. If something's inaccessible, it's not accessible. If something is inconsistent, it's not predictable, right? It's not consistent. If a person is inarticulate, they're not very articulate. They don't express themselves well in words. If a person's inconsiderate, then they aren't considerate of other people, maybe their feelings, maybe what they want to do. And if something's inconceivable, it means that it is so not conceivable, we so cannot understand it. So indefinite is a word you're going to hear a lot throughout the rest of this lesson. And if something is indefinite, it means it's not definite. It means that it's able to change. Speaking of indefinite, a liquid is a state of matter that has a definite volume, so a volume that is consistent and that will always remain the same, but a liquid has an indefinite shape. It has a shape that is going to be able to change. The particles in the liquid have enough energy that they can overcome some of those attractions between them. They're going to be able to slide past one another, and they're going to be able to take the shape of any container. If you pour water into a glass, it's going to take the shape of that glass. If you pour the water down the sink, it's going to spread out and it's going to start to take up all of the area available to it in the sink, or it's going to be drawn by gravity down into a drain. Liquids have a couple of unique characteristics. Some of these you might have highlighted as being characteristic properties in your Chapter 1 learning portfolio. One of those characteristics of the liquid is surface tension. This is a force that acts on the surface of a liquid and tends to keep it in the most minimal amount of surface area possible. So surface tension, you might have demonstrated by taking a glass of water and sticking something like a paper clip or a marshmallow on the top of it. The surface tension is going to keep that particle, that marshmallow, that paper clip, whatever it was, from sinking. Surface tension is also going to cling all those particles of water that are together, even more so together. So surface tension is going to cause the formation of droplets like the one that you see on the screen. Liquids are fluids. That means that they're substances that are able to flow. They have different viscosities, however, depending on the characteristics or the atoms and molecules that make them up. Viscosity is a resistance to flow, and this can apply to both a gas and to a liquid. Usually, the stronger the attraction between molecules, the more viscosity the liquid has. So an example of a liquid with a high viscosity might be molasses or maple syrup or corn syrup. They are substances that are liquids. They're able to flow, but they are so stuck together. They have such strong attractions between the molecules that they're going to flow really, really slowly. Water, on the other hand, has a fairly low viscosity. It's able to flow pretty quickly. It's a sign that there's a little less attraction between all of those H2O, those water molecules. Now we come to our gases, the third and final state of matter that we're going to talk about today. A gas is a form of matter that has both an indefinite volume and an indefinite shape. Remember, indefinite meaning able to change, means not defined. The particles in the gas move quickly, so they're able to break away from one another and they're able to move as far apart as they want. So the particles of a gas are able to occupy any amount of space so long as that space is an option. There are certain substances that are going to block a gas from being able to expand beyond what it might want to expand to. For instance, if I were to take a gas like my breath, the carbon dioxide I exhale, and blow it into a balloon, that latex or plastic that makes up the balloon is enough of a barrier that it can keep those gas molecules from expanding out into the air. It can trap them inside the balloon. The amount of empty space between a gas particle and the next gas particle has the ability to change so long as the gas has enough space to expand. If the gas is compressed into a small space, which can sometimes happen, then that gas is going to have a really high amount of pressure. When we get to our sections on the gas laws, in Section 2 and Section 3, we'll talk a little bit more about this changing of pressure that gases are able to produce. So that's it for Section 2.1. The homework for Monday is going to be the Section 2.1 notes. You can do those in your notebook or you can choose to type them, but regardless, they should go into the Dropbox no later than Monday at 2. There are also a number of extra credit activities available for you in this lesson. They are completely optional. If you turn in a picture to show evidence of what you did, I will give you extra credit as early as Monday at 2 o'clock. Just a quick note about other states of matter. We don't often talk about plasma, but that's a state of matter that has a ton of energy to it. We see it on the sun. We see small hints of it most likely near the center of the Earth. There are other states of matter too, and if you know about them or if you want to look more into them, feel free. We're not going to go into them so much in this unit because they're not as present in the chemistry that we're able to do, but they do exist and they're kind of cool, so you might want to check them out. Let me know if you have any questions. Talk to you later.